word here, and I cannot hear you. You've got to project your voice.
My name is Deion Floyd, and this is my partner here at Custis. And our project, and we're Team J, and our project is rock mechanics. Unfortunately, one of our other teammates, Khalid Cobb, was not able to be here. So, an introduction to our project is identifying rocks, the formation of rocks, mine exploration, explosion, rock sample preparation, physical properties, rock mechanical testing, and instrumentation.
What is rock mechanics? Rock mechanics is the study of mechanical testing during rock, which we test stress levels, stress conditions of mine movements, and certain types of rocks. The basic three types of rocks that we're using for our rock mechanics study are igneous, metamorphic, and sedimentary rock. As you can see above, we have the igneous rock, the metamorphic rock, and your sedimentary rock. How to identify rocks as a rock mechanic. We identify rocks by the color of the rock. As you can see in our right corner above, the color of the rock is like a reddish, greenish, yellowish color. And we also can tell by the texture how smooth the rock is, how rough the rock is. And we also can tell by the grain size of the rock, the proportion of the rock. We can also tell how to identify rocks by certain types of acids. The formation of rocks. As you can see on the volcano to our left, the intrusive rock is a magma inside the magma chamber. And the lava explodes, and the lava that's outside of the volcano, over time the lava sets, that's extrusive rock, which is igneous. In the picture of the volcano, that's the volcano erupting, which is the same as extrusive rock. And our little diagram right here is precipitation, which is running off sedimentary rock into water areas. Over time, the sediment rocks pack into each other, and this is our sedimentary rock.
For mine exploration, the picture to the top right shows like a typical topography layout, and it shows the different levels for topography. And to the top left, that shows the holes drilled inside the surface of the ground to get underground. And the picture to the top, to the bottom right, it shows a bunch of core samples. Well, the picture to the top left is called the jumbo drill, and it drills horizontally in the tunnels. The picture to the bottom left is called the drill wagon, and it drills vertical holes into the surface of the ground. And the picture to the top right shows what an actual mine quarry looks like. And to the bottom right, it shows a real explosion of a mine.
How to prepare our rocks for preparation? We prepare our rock by getting a large rock sample, which is really huge, and we take it to our coring bin and core out the cylinder rock structure. And if we take our core rock structures, we put them in the cutting machine, as you can see the picture to the right. We cut the sample at least maybe like 2 inches or no above like 2.5 inches. And after we have cut our rock, we take it to the grinding area. The grinding area smooths the surface of the rock on both sides. After we smooth the rock, we take it to this instrument to the bottom and test how smooth the surface of the rock is. If it's not smooth, then we have to continue to grind the top of the rock. We have to be very precise of using other further tests. Physical properties. After taking our core structures, we do physical properties by measuring with that instrument over here and the pictures you see with the arrow pointing down to another structure is the holes of a rock, which may be the water content. We have the water content.
Okay. After finding the physical properties of rocks, we move on to rock mechanical testing. And we use the UCS test and the surcharge test. And the UCS stands for uniaxial compressive strength, which we use the machine to test the rocks, under stress levels. In the surcharge test, we use that to find how dull the drill bit gets with time. And after we use the rock mechanical testing, we move on to instrumentation. And we use tunnel deformation and LVDTs. LVDT stand for linear variable differential transformer. And it basically measures the deformation of a rock. In this case, we weren't digging any tunnels, so we were examining the holes in the rock.
We did a couple of test procedures, and we have a video for you. After our procedures we did in the last slide that you've seen, we graphed our measurements. First we did calibration, which tests the voltage and the displacement in our rock. And we tested two types of rocks, limestone and gneiss. As you can see on the limestone, as a long period of time went by, our voltage got higher. And the gneiss, as the time went by, our voltage, would just didn't increase or decrease. It just stayed basically the same, and which tells us that gneiss is harder than limestone. We took a visit to the Grand Mine company, which is a company that's based on mostly limestone.
And the picture to the top left shows we'll start with the truck, because the truck first brings the rock into the crusher. Then the crusher releases the
Okay, I do it. As you can see in the bottom, we were inside the mine, and after the explosion happens, we have a machine that comes and knocks off debris, like these particles, off the inside the mine. And we have the truck over here, which collects, those type of certain limestone when you use like pure limestone. After they take the limestone out of the mine, they go to the crusher, which crushes the limestone into fragments. And after the fragments are obtained, they are put into this kiln, which heats the limestone into a powder substance. We would like to acknowledge Ms. Jody, Ms. James, Dr. Lauren Romatowski, our grad student Abraham Farouk from the mine company Great Mine, the SEAMS program, and our residential staff and teachers.